Hello everyone and welcome to the channel. In this video we are going to be building our very own ransomware. I will be loading up the scripts that I have received from ChatGPT after some educational prompting to showcase exactly the mechanics of how ransomware works. Now, for those of you who have maybe never heard of the term ransomware, that is a piece of software that loads on a victim's computer, encrypts their files, and the only way that they can get those files back is by completing a list of demands, typically by paying some money through cryptocurrency to the attacker to unlock their data. Now, I must disclose for this video that everything here is for educational purposes only. I am going to be doing everything through virtual machines. No real systems will be impacted. I do not condone illegal activity whatsoever. This is strictly for educational, informative purposes only. If you do this without consent on anyone's machine, with or without malintent, you could and probably will go to prison. So with that being out the way and disclosed, let's go ahead and get started. We know what ransomware is, what it does, but rarely do we talk about what actually goes on underneath the hood. So we're going to be going through each piece of what it contains to achieve their objective, the attacker's objective, and then we will actually load up the Python scripts so that we can see live how these services run from both the victim and the attacker's machine. Let's get started. Before we go into the steps, let's go into each element of the ransomware. So the ransomware consists of an encryptor. That is the script that will take in some data, probably some file, and then lock that data up with a key. Where does that key come from? Good question. So the ransomware will need to generate a key. So there's two parts now. We have the encryptor, which is the thing that locks the data, and then we have the key maker, which is going to be used in tandem with the encryptor to lock that data. Now, to unlock the data, we would need to use that same key. So there's our third piece of the ransomware, the decryptor. So far we have the encryptor, we have the key generator, and we have the decryptor. Now, once the data is locked, it will need to display some message on the victim's computer to let them know what has just occurred and to propose their list of demands, which is the fourth part of ransomware. Now, it may be obvious to you that the attacker does not want the key to unlock the data to be stored on the victim's computer. So in the ransomware, there is a fifth component which will help transmit the key to the attacker. So after the key has been generated, after the key has locked the data, the key will then be sent to the attacker's machine, where they will then mark it with an ID number to keep track of which key belongs to which victim's machine. All cool? Makes sense? So those are the basic parts of ransomware. Let's go into the steps in which they occur on the target's machine. So here I have it all drawn at once, but I will go through one by one. Okay, so first thing that happens is that the ransomware gets infected on the target machine. How that happens is a totally another video, but let's just start here. The ransomware is on the victim's computer. It gets executed somehow, and the first thing that occurs after execution is it will generate a key. Then it will find the files for which it needs to encrypt and lock that data. The key, as mentioned before, will be sent over to the attacker, where they will mark it as this key belonging to victim or target number 1. At this point, the victim's machine will then show a list of demands that they must complete in order to get their key back from the attacker. Now, once those lists of demands have been met, they get sent to the attacker along with their ID number. The victim doesn't know that this is being sent along, right? Or even how this list of demands is being sent. It could be a transaction ID that comes from some cryptocurrency deposit into the attacker's account where they can confirm it there. But the concept is that the proof of the list of demands being met along with the victim's ID number gets sent to the attacker, where they then confirm that this is actually what took place. At this point, they refer to the victim's ID number, finds the key associated with it, sends it back to the victim, where the data is unlocked and they retrieve their files. Now, I deleted the ransomware that's actually not what happens. The ransomware stays there, and you have to then delete it and pray that they don't attack your machine again.
Bruh.
And that's how ransomware works, from the basic elements to how the attack actually occurs on the machine. So if that wasn't cool enough for you, there's more.
But wait, there's more.
So for this demonstration, I have two machines that are running on VirtualBox. On the left-hand side, I have an Ubuntu machine, which will be the victim or the target indicated as user at Ubuntu. And then on the right-hand side, we have the attacker machine indicated by this dragon on Kali Kali. I'm going to list out the files or the scripts, the ransomware that's been installed on this user Ubuntu machine. Now, these scripts, I did write them with the help of ChatGPT. How I got ChatGPT to write those scripts was purely by just talking about cool video ideas and kind of leveraging what I know about cybersecurity, and somehow it has happened.
Bruh.
So here we are. So as we saw in our diagram, the encryptor is a big element of the ransomware. Let's go ahead and open that encryptor script, and let's start at the main function, where you'll notice that it's really only 3 steps that occur. First, we generate a key, then we encrypt the files with that key, and then upload the key to the attacker's server. The logic behind those functions can be seen here. You can see it just goes through each file, uses our cryptography library to encrypt the data, and then sends a print of files encrypted successfully. Now, for the upload key, this actually has a little bit more going on behind it. You can see that it's sending a post request to the upload key endpoint. Now, I'm running this within a sandbox or a virtual network. So this IP is the IP address, the private IP address of the Kali machine on my bridge network. And there is going to be a app route of upload key, which we can actually open right now. And this is going to be the server logic that handles each one of these routes. So for example, when they send a upload of the key to this endpoint here, it will take that JSON data, it will pull out the key value, and then store the key for that session. Now, notice the word "for that session." You'll notice that there's also a session that's being used here for this post request. That's because there's going to be a cookie that will be stored on the victim's machine, so that way when they complete their list of demands, they can send back that cookie as an ID of which key belongs to them. That would be equivalent to the 0-1 that we saw on our diagram before. Now, the attacker still needs to inform the victim of what's happened. So let's take a look at our ransom note script here. And basically what it does is it pops open a window, shows a title of your files have been encrypted, and when they click on a button, it will launch this task script here, which will show them their list of demands. So let's go ahead and pop open that script there. So let's take a look at the main function here. Here you can see we get the task, and while there's task, check whether it was a status of success or a wrong answer. And if there's no more tasks to be completed, then it will try and fetch a key to decrypt the files with. Let's go into the logic of each of these functions. So first we have to get a task, which is going to make a GET request using the session's cookie, which was stored from before. Notice that we're actually opening it up right here, where we're loading up the victim's ID through the session cookie, and we send that over when we request any of these apps endpoints. So when it makes a GET request to the attacker's server for GET task, which is defined on the attacker's server here. Now the tasks are very simple. It's really just what is 2 plus 2, what's the capital of France, what is 5 times 6. There's no actual cryptocurrency exchange going on here. This is just showing the mechanic of triggering that proof of completion on the list of demands. And you can see that if there's no completed tasks, it'll set an empty array for it or an empty list for it. For each task, it will send the task so long as it has not been placed in the completed pile. This is just to verify that no tasks have been completed more than once. Otherwise, it sends the task over. If there are no other tasks for the user to complete, they will receive all tasks completed in a 200 message. After the victim gets the tasks and they answer the question, they will then submit their answer to our submit endpoint, which is handled at this app route right here. And you can see it just takes in the task ID, it takes in their answer, checks whether or not they're correct. If so, put it into the completed tasks, send back a success message, otherwise a 400 error code of incorrect. Once all of the tasks have been completed, the victim's computer will attempt to run this get key function, which will hit our key endpoint defined on the attacker's machine here. So here you can see, using the session and the session cookie, it tries to grab that encryption key, and this will only happen if all of their tasks have been completed. That's what this logic is right here, right? And the way that the attacker's server verifies all this is by signing the cookie through each of these requests and responses. So upon the creation of the session, the attacker's machine, the attacker's server, will sign the cookie with some secret key to verify that it hasn't been a falsely minted token. So assuming that the session is legit and that all tasks have been completed, they will receive back their key. At which point the victim's computer will take in that key, take in the same target folder that was used on the encryptor script, and decrypt the files. Now that is the entirety of the victim's machine, the attacker's machine logic that is occurring in this ransomware. Let's actually take a look at how it runs, Now, the attacker's machine will be running the server, that is to receive the keys and to send back keys upon confirmation that the list of demands has been met. So the way in which the ransomware actually executes on the victim's machine can be a variety of ways. But for simplicity and the sake of this video, I'm going to just execute those scripts manually. So here I have a directory of test files. Let me go ahead and show those to you. And you'll notice we have file 1 and file 2. We can open those so you can see how they look before and after the attack. It just says some really important data, also really important data. You can imagine that this could be a variety of different types of data though. So first step of the attack is to encrypt their data. The encryption happens, and then the key gets uploaded to the attacker's server, which we can see right here. Now, this key is now associated with the victim's ID, and that victim's ID can actually be seen here. It created a session token, which will be sent back upon completion of the tasks so that the attacker's machine knows which key to send back to the victim. Now, let's take a look at our test files once again, and you can see that they are no longer readable important data. It's completely messed up. It's completely encrypted. There's no way that we can decrypt it unless we were able to get this key. Now, the attacker is going to want to show the victim what has occurred. So their ransom note script will run, and here you can see we have a box that says, "Oh no, your files have been encrypted. To retrieve them, complete the following tasks." All right, and it pops open our 3 questions. What is 2 plus 2? Let's put a wrong answer. 1. We got a failure. You can see that that post request verifies, sends back a 400. Try again. 4. Great. Now you'll notice that for this session, we have 1 task that has been completed. Okay, we'll do Paris. And then the last question is, what is 5 times 6, which is 30? And at this point, the key for that session, after verifying that all tasks have been completed, gets sent back to the user, and their data gets decrypted. We'll go ahead and open up our test files again, and our really important data is back. It all seems so simple now, right? It's really not that complicated when you understand the steps that go through. You'll notice that even Microsoft or Windows is trying to get people to put their data on OneDrive to protect them from ransomware attacks, because if you have all of your data backed up, why would you have to pay the ransom or complete the tasks to get your data back? You would just re-download it from the cloud. Overall though, we never talked about how the ransomware actually gets onto the victim's computer, which is obviously a huge step in the process. Once they've gotten the malware or the ransomware on the computer, you know, it's basically game over at that point if you have anything that's of really important or proprietary information. And with that, I hope you had a wonderful time in this video. I hope you learned something very insightful. Don't go do anything illegal. You'll get locked up. Don't forget to hit that like and subscribe button, and I will see you next time. Bye-bye.